Let's talk about some scatter plots. This one is going to be pretty, how do I say this? Pretty vocab heavy, so you're definitely going to want to write down some of these terms. I'm not sure that I would copy down everything word for word, and I definitely wouldn't necessarily copy down all the graphs. So I'm not sure if maybe you'd want to screenshot some of the stuff and take pictures, or just kind of sketch. You know, maybe the best bet would just be to watch, at least from sort of slide to slide here, and take notes afterwards. See what seems important and doesn't. All right. Anyway, let's move on. We're going to talk about scatter plots. The scatter plots is it's a graph that we're going to do, show a relationship between two sets of data. Okay, it's when we want to take two different things and compare them. A lot of times this is also known as bivariate data. So let me write that in here real quick. It's called bivariate data. Let's do a little handwriting. So it's okay, bivariate data. Ooh, that's nice and big. All right. So there you have it. Okay, in case you see it again. In this example I'm showing you, we have person's height versus their weight. And what we're doing is we're using these data to see if there's any sort of connection between the two things. And that's what these idea of scatter plots, and you'll see. All right, so here's an example, right? We have a local ice cream shop. They keep track of how much they sell according to how much the temperature is outside, right? Now this is using degrees Celsius, so it might not be maybe as intuitive, but you can still see that the temperature on the left and then the ice cream sales on the right. So as they go through them, right, there's what, 12, that would make sense, it's 12 months, right? Maybe like January, February, March, April, May, June, July, August, and on and on and on, okay? Although maybe, yeah, that looks about right. And then how much sales they do as that goes through, okay? So let's see what this looks like when you actually put on a graph, okay? So from the reason we do this is, you know, you look at this chart and I don't know, can you tell anything specifically from it? It's a little bit hard. So we put it in a visual form, okay? And as you see this, I'm hoping that you start seeing that there is some kind of connection, right? It looks like there's maybe a pattern. And it's a little easier to see a pattern, I think, when you can see the data put onto a graph. And let's go ahead and let's look at what that looks like here, okay? Now this line that we go through, we'll call this a line of best fit. And that's also called a trend line, and something we're going to do in class, or maybe we've already done it in class, depending on when you're watching this video. So the idea is when you do a line of fit, you want to make it go through or sort of mirror the data as close as you possibly can, okay? Now, the line doesn't have to go through any of the points, okay? Your line of best fit does not have to go through any of the points there. It can, but it doesn't have to. And you want to make it so that there's going to be as many above the below line as there are below. So in this example, let's see, let's count. We've got 1, 2, 3, 4, 5, we'll say, above the line, and then what we got below? The 1, 2, 3, 4. Okay? Well, that means there's 9 that are not on the line. You can't have the same amount on both sides that way. But if there's 5 above and 4 below, and you know, you just got to make it as close to the data as possible. Okay? So this line does a pretty good job of that. And then what we're going to do is we're going to use these lines to create equations. Okay? So here's another example, right? On the bottom, on the x-axis here, we have the sea level, or the year, and then the sea level in millimeters, the average, okay? So you have the course of it over a whole bunch of years, right? And so inside of each of these is probably somewhere along, you know, different days, right? And they put them all through here. Well, you know, if you look at this, it looks like, to me, the sea level is rising, okay? And that's what this sort of line is saying, all right? And you should sort of see that, I'm hoping, is that there's a pattern, an increasing pattern here. Okay, so like I said, we're going to create equations of lines. We're going to do a lot of practice with that, and this is why we were talking about slope and intercept in class, is because you're going to need to use this line and find some points on the line in order to find the slope, right, or the rate of change, how this line moves across the graph. And then you're also going to need to be able to predict where does it start, right? You're going to have to find the y-intercept here. Okay, so when you use your line of best fit, there's two different things you're going to do. One is you're going to do interpolation, okay? So inter, meaning between, and polation, meaning poles or extremes, okay? So you're going to go in between, okay? You're going to find somewhere in between. So this would be like, let's say we're going to try to find the temperature at 21 degrees, okay? Using our line of best fit and interpolation, we're going to say that the sales would be about 480, okay? And you could use this as a predictor. And again, it's not a perfect predictor, but it is something you can use to predict how much sales you will do, right? So maybe if you know the temperature is going to go up, maybe it's time that you order more ice cream because you don't want to run out. That would be bad business, okay? So if you can do interpolation, which means in between the points, then you can do extrapolation, okay? And I'm not even so sure I'm saying that right. I know when you talk about it as a verb, you will extrapolate the different data. And so what we're doing here is we're taking your line, right? And what you're saying when you say extra is outside of, okay, or over. So what we're going to do is we're going to extrapolate the data based on the trend, okay? Now you have to be careful with this, because just because the line of best fit is there, you're using it to predict the future, okay? It's still just an estimation. You're estimating. You're saying, well, if the temperature was 29, based on our current information, we're going to assume, or we're going to guess, that we'll do $750 in sales of ice cream, okay? But you have to be careful, because if it's 29 degrees, maybe people don't go outside. Maybe it's too hot, okay? Maybe you sell way more than 750. But if you had to predict, this would be one way of doing it, all right? Again, you just need to be careful. So let's move on. And there's this thing called correlation, okay? And I had to keep myself from saying it multiple times in this video so far, but when two things are connected, right, they're going to have some type of correlation, right? When they both increase together, for instance, the ice cream, both of the ice cream and the sales, or I'm sorry, the sales rose as the temperature rose, that would be a positive correlation. If something is a negative correlation, like where one thing increases and the other thing decreases, right? Like, let's say, let's see, I can't think of anything off the top of my head. If something increases and the other decreases, so you could say as your height increases, the distance between your head and the ceiling decreases, okay? I mean, that's not a very good example, but it is an example. That would be a negative correlation, okay? So correlation is a combination of the word co, meaning together, right? And relation, so together relation, or how they are work together, okay? Your relationship between the two things, all right? And so let's do a look at this, okay? So here are all the different things, right? So a perfect positive correlation, okay, is going to be straight across here, right? This one is a high positive correlation, right? Like as one increases, the other increases. Is pretty close. You have a low positive correlation that's going to be, you know, there is a general trend going up, but it's going to be hard to predict from there. And then no correlation, meaning like the things are just all over. The two things that you're measuring are just not related, okay? Something like that might be let's say the size of your hands and how much money you make. You know, that probably has no correlation. Maybe it does, but I'm guessing it doesn't. And then the opposite, okay? Scattered pretty well, but going down, negative correlation. And we'll talk about what these numbers mean later. And then a high negative correlation, meaning they're pretty close. And then a perfect negative correlation, meaning those things are straight down, okay? All right, so let's go ahead and let's take a look at a negative correlation, okay? And here's one. Let's say the birth rate versus income, okay? So this would be where they talk about the birth rate in countries where people make more money per person. The birth rate, right, the number of children people have goes down. And places where they have very low yearly income, birth rate goes up. Okay, and so here we have a bunch of different countries, and we have the yearly production, and we'll graph, okay, the birth rate compared to the yearly production per person. And that's, yearly production, meaning how much money they make. Okay, so you can see the average in Norway is $40,000, and the average in Madagascar is $800. That's a huge difference there, right? And then you can see in Norway, people have an average of 1.78 children per couple, right? And then in Madagascar, it's 5.7. So really, it's sort of like 2 and 6. Obviously, you can't have 1.78 children. That's why it's an average. And so here we go. Here's our, this would be our data. Okay, as it all comes through. The yearly income is on the bottom. Okay, so you can see as the yearly income goes up, the birth rate drops. Okay, and one of the other things you might notice is there aren't very many data points over here, right? Not a whole lot of data points. In here, a lot of data points, right? So if you're looking at the world, right, overall, the average income, okay, if you're looking at average income, the mean would probably be in here somewhere. Okay, just with the sheer number, right? So the mean or the median of yearly income is in there. So I don't know what it is in the U.S., but I'm guessing it's probably in here somewhere. So anyway, as you can see, this would tell you, this is all your data. Now, what does this tell you? And that's sort of one of the things that people do with these statistics. They say, okay, well, why? Why would the income, as income goes up, does the birth rate go down? Why does this happen? And in this case, is a line actually the best way to represent this correlation? Could there be some other way? And so that's one of the things I want you to think about. In fact, maybe write that question, see if you can come up with something better. Maybe think about a possible effect. Like, what is this data? What does it talk to you? What does it tell you? What is it? What do you pull out of that? And we'll talk about that in class. Okay.